You didn't have to tell me how many people were watching online. That is nerve-wracking. Thank you. I also didn't expect him to read the entire biography because I put some really funny stuff in there. 15 minutes, we're running super late. I know everybody wants to get to the event, or the people online probably want to go and have a snack, so I'm gonna jump right into it. He gave me a good bio, so I'm not gonna give much of an introduction. Yeah, let's move right into it. Open source softwares, in higher learning specifically. So there's a big timeline of computer and computer things. Back in 1939, Bell Labs created the first real calculator, the calculating machine. 44, the Colossus machine came around that was actually able to introduce vacuum tubes into computing. So you had the two of the big primary things for computing, which is processing and storage. The Colossus machine was also one of the machines that was using for deciphering codes and such during the World War II. That's pretty cool. But at that point, it was mostly mostly governmental environments and organizations that were doing all of the complicated stuff with computers. So 48, University of Manchester was one of the real big moves from governmental companies or governmental organizations into higher learning organizations to actually start pushing computing forward. And that was 1948 when they made the Manchester Baby. That was the first machine that introduced RAM. So now at this point we have processor, we have RAM, we have storage. So we got the three things that actually make up a computer. Now, at this point, computers were freaking huge, right? The entire size of the room. So Digital Equipment Corporation came through and they created the first self-contained programmable data processor. They didn't want to call it a computer because a computer was massive, and this was self-contained and was trying to get smaller and smaller. And that started in 57 and it went all the way through 90. The first couple iterations, they broke some great ground because they were starting to get self-contained, but they didn't actually sell very much. The PDP-3 only sold one unit, and it was to the CIA, which is kind of wild. But however, when they moved into the 6s through 11s, they started going into universities primarily. And that's kind of where we get started with operating systems and where it started to influence in universities in particular. So at that point, the PDPs were given to a bunch of universities, and universities were actually starting to work together a bit. And you would end up in universities, like most of you guys are here, you would see these kids who were able to just hack up code and hack up stuff to make the thing work. And that's kind of where the term hacker came from. And so you end up with these college kids who are actually a community of tinkerers that were trying to get this stuff to work. And the cool thing was, when they were a community like that, they were able to share their successes and share their failures with one another, commiserate with one another, and start to really share the things that they had and that they believed, that they came up with and that they were able to solve. So one of the awesome things at this point, because of the sharing and the collaboration that was going on, it was considered a professional courtesy. Anytime you put out some sort of instruction, some sort of operation, some system that would manage operations on a computer, that you would offer the source code along with it. But that changed a little bit in 1980 when Richard Stallman decided to fight a printer. So Richard Stallman was working at MIT at the time, and the MIT was given a printer by Xerox, and this was the very first real printer like the printers that we know. At the time, Xerox was making the photocopier. You put a piece of paper down, it makes a copy of it. This one, you actually took data, sent it over the network, and put it onto the printer, and the printer decided to print it out. And it was fantastic, except it had a few problems. There were some issues with the networking specifically, lots of paper jams, of course, because they always had those. But there were some situations wherein the data would go from the machine on the network over to the printer and get lost somewhere in the pipes. And the only way to address that was to actually work with the operating systems that was maintaining the computer itself. Here's the problem. Xerox decided to send the code not paying attention to the courtesy of including the actual source code with it. They compiled it into binary. So all it was bits and bytes. And Stallman, although he was a good programmer and a great engineer, he didn't really do too well with bits and bytes and such. So remember I talked about that community of folks and community of hackers. He decided to go to Harvard. Now, at Harvard, they had two machines. Also, they had a PDP-10 originally. That was actually the machine that Bill Gates wrote the first version of BASIC on. And they got themselves a PDP-11, and they weren't able to talk to each other. So What they did was Stallman reach out there after they figured that out, and he told them, hey, I'm working on this machine that's got a similar network issue that you guys are seeing with the PDPs. Can I have your source code? And they gave it to him because that's what hackers did at the time. That's what people in community do when they're working with community-based operating systems. We share stuff. And so he shared that with him. He was able to update the code and fix the issues. And that's fantastic. He was able to go forth and do also, now at the time, so that was like the first real situation wherein there was an operating system that was being openly sourced where the source codes were available to whomever. And that's fantastic. Of course, OSs went all crazy from there. Unix was made by Bell Labs. BSD came off, which is based in Unix and just turned into this big legal nightmare. DOS eventually came out from Seattle Computers. The GNU project was started by Stallman, and then it kind of fell flat, and it really didn't really take off the way that he wanted to. Windows ended up, Microsoft ended up purchasing DOS and then building Windows off of it. And then at that point, you had a machine that had an operating system, but the operating system belonged to the people that sold it to you. You couldn't touch the operating system. You can change configurations, you could make it do stuff, but you don't get the code. And tinkerers, hackers, people like us, like to look at the code. We like to have our own systems, like the gentleman before me that was working on his system. He wanted to take a piece of machinery and make it work for himself. He needed access to the code. And so, 1991, Linus Torvalds out of Helsinki decides to to write an awesome operating system that we know as Linux and just give it to everybody. Anybody who wanted it could have access to the source code that could actually drive a computer that we have right now. And that's fantastic. And Linux just blew up from that point because it was free, it was open, it was customizable, it was available. And so now we got a Linux on all of the top 500 supercomputers, 3 of the top 5 websites of the world right now. Actually, this is as of 2023, so this might be a little dated. 96% of the world's top million computers and 90% of all cloud services are running off of Linux right now. And it's a free open source software that everybody uses. And these people are making lots and lots of money off of this stuff. And that's fine, that's fine. But the base of it is a free and open source piece of software that started out with a base in higher learning and in research. So, here's the weird thing when we talk about research specifically. Now, before I went into the research area, before I became an engineer, so right now I work for a linear particle accelerator in Lansing, Michigan, in the US. But before I started working there, I worked in web hosting, and like my bio said, I was a chef before that. This is the first time I've ever worked in a place where we didn't create a product. And that blew my mind when I first considered it. Like, how do you pay for stuff? How do you create things? What's the drive behind that? And the reality happens is that because we don't make a product, it fundamentally changes the way that you look at the work that you're doing. You don't get funding quarterly because of how many things you sell. Most of the time, funding comes in the form of grants, or you try to get as much free work as you can from folks who are just really interested in things. And the crazy thing about grants, at least in the US where I'm based, is grants usually come from the government, and the US government can change over every 4 years. So you can get a grant that's great and it's moving, it gives you all this money, but then 4 years, it's just gone. So what do you do with the money that just changes out of nowhere? You end up employing people that are actually seeking out knowledge and looking to push forward the boundaries of society as we understand it. That's what science does. Technology changes quickly. Every 6 months you get a new version of something. Every 3 years you're obsolete at that point. After 3 years, most folks that are working in technology are looking for a new job. But science doesn't change. The numbers doesn't change. Only technology moves quickly. You plan, you test, you plan, and you keep on going from there. So, let's get back to Linux. At CERN, at FRIB, at Fermilab, at NERSC, they're all using Linux to drive so many of their great research that's, like I said, just changing the world as we see it today. Why? Well, like I said, that first part about the funding is a big thing. It's free, so you don't have to worry about having to change the way you're funding or when something just changes randomly because we get a new administration. Not just the new administration, but we're college kids. Well, I'm not anymore. I'm an old man at this point. You guys are college kids right now. You're not going to spend money on the stuff that you're studying, gaming, right? When's the last time you actually spent something on a work site? I can't tell you how much money I spent on my gaming stuff, especially when I was at your age. That and going out and have a good time every so often, a few drinks. Anyways, I didn't say that. So it's customizable is the other cool thing. super granular, all the way down to the hardware itself. You can change the actual way the bits and bytes interact with a specific hardware as it goes. And not to mention, or also that goes along with that, is built into the way it was actually created way back in the day is this community that comes with it. All these folks, we're a community of tinkerers that just like to make things work and like to share what we got, share our successes. And so that means that Linux really moves forward, really helps to move that stuff forward. So we're looking at science specifically. What's the big deal with science? So I had to learn the hard way, honestly, that science isn't science unless it's recreatable. You can't just make one quick discovery and decide that you've changed the whole world or you come up with a new paradigm. Science isn't science unless you can come up with, you can find those discoveries, you can do those testing, and then you can share it with the rest of the people that have been working on it. And it's not important unless we're actually learning something and you're doing something new. Also, science moves incredibly, incredibly slowly, like I was saying earlier. And we don't create things, we break ground. So, with that in mind, we're going to move, so with the idea of science where we are right now, we're going to move into what we consider the future. And anytime I talk about the future and I talk about technology, somebody wants to tell me, how do we use AI with this? The future of research isn't AI, and I'm very sorry that I had to say that. I can't tell you when the Matrix is going to happen, and I can't tell you when the Terminators are going to attack, because that's not what science does. Science moves much more slowly than the technology we had yet. So when we're looking in the research, the OSs that research is going to favor as you move into the future are going to take those fundamental ideas that I gave about science early on and kind of build off of them. The first thing is that when you're breaking ground in research, you're trying to figure out how things work. And fundamentally, as our technology has grown, the way things work is just getting smaller and smaller. At my job specifically, we work with subatomic particles, little neutrons that are kind of shooting into the atom of a nucleus. It's tiny, tiny, tiny. And we're talking picoseconds. But picoseconds, a millionth of a millisecond. It's crazy the way that they're measuring this. So not only smaller, it has to be smaller, it has to be lighter weight, and it has to start to move much more quickly because you're capturing these things. Like the Higgs boson was recently discovered in CERN. Rather, it was recently proven to be discovered in CERN. It was already proven by a math. But they actually found it, and it exists for something like a millionth of a picosecond. It's a tiny, tiny amount of time. So the operating system has to be able to keep up with those sorts of discoveries as well. On top of that, our world is getting smaller. And that's good. We can share this stuff out with the rest of the world and with the rest of humanity and help kind of push us forward. However, that also means that there's a chance that bad actors can come around. So operating needs to also maintain some level of security and some like-mindedness about how we're going to make sure that bad actors don't misinterpret or take the research that we've been doing and use it in a nefarious manner. And the last thing, because science moves so slowly, we're no longer looking at 3 and 5 year terms of support. The longer the amount of support, the more. When I was in CERN, I got the great opportunity to go and visit CERN, and they were working on a project right now, breaking ground and doing planning and finding funding that doesn't actually start till 2045. We're talking 20 years in the future. So if we're starting to look at the operating systems that are going to be able to manage that product, we have to look at longevity of the support that's actually going to come from those guys. So that's kind of what I had today, a quick 15 minutes introduction into where we are with operating systems and science. We have a whole lot of ground that we can break. We're learning stuff so quickly. We've got a whole bunch of fresh minds. It's you guys specifically that are out there like willing and able and looking forward to do something awesome. And you'll find, I think, that using these sorts of open source software is going to be one of the fundamental backbones of how we actually push ourselves forward. So, hope that was all right. Thank you guys for the lovely time.